Good afternoon, everyone. In the previous lecture, we had seen different types of handling of the sample depending on the physical state of the sample, its solubilization characteristic, its physical properties. Now, what if there is a technique in which you don't have to dissolve the sample at all in any of the solvent? What if there is a technique in which you don't have to prepare your sample for analysis? No trituration, no pelleting, no formation of new gel, nothing. Just take your sample, put on the machine, and machine will give you the reading. In IR spectroscopy, this is actually possible if instead of relying on absorbance of infrared light, we rely on the light, the wavelength, the electromagnetic radiation that is reflected by the surface, reflected by the analyte surface to be more specific. Now, if any object that you see, it has a yellow color, what does it mean? It means that except that yellow color, the object is reflecting all other colors. Okay. uh, Perception of the color is totally different. Today we are going to see what are the techniques of sample handling which actually do not require preparation of sample. So those techniques are infrared reflection techniques. They are called as reflectance technique also. So infrared spectrometry has found a number of applications, particularly for dealing with solid samples that are difficult to handle, such as polymer films, fibers, foods, rubbers, agriculture product, and many others. Now, every type of the sample mentioned here has own challenge. Like if it is a fiber, how will you prepare palette of fiber? How will you dissolve the fiber, which is generally a polymer, into a solvent? So the challenge in case of fiber, same with polymer films. Same goes with food. Food has a lot of complex molecule inside it. How can you dissolve all of them? So every type has its own challenges. So mid-infrared reflection spectra, the same spectra we used for absorbance spectra. So mid-infrared reflection spectra are similar in general appearance and provide the same information as the day for their absorption counterparts. So basically both the spectra, they appear very similar. If they appear very similar, they will give the similar information. So reflectance spectra can be used for both qualitative and quantitative analysis. Usually adapters are provided to fit in the cell compartment to change the IR instrument from absorption to reflectance. Now these adapters, I will I will try to show you at the end of lecture through video, because in previous lecture I tried to on the video but that was not working. So I will finish the theory today and then I will show you the video if time permits. Otherwise, I will simply provide you the links. So there is a difference between transmission and reflection FTIR technique. Basically, both these techniques are FTIR only. That is, at same time you are throwing all possible wavelengths simultaneously on the sample. In one, it will pass through the sample. In the other, it will simply get a bounce off the sample. But while bouncing off, if significant conditions are provided, there may be a small part of the infrared radiation that is penetrating the sample and then bouncing off. We will see what is IRS. This type where the IR radiation penetrates very slightly inside the sample, it is called as attenuated total reflectance, because not all light is getting reflected. Some part of it got reduced. It is reduced means attenuated. Some part of it got attenuated. That's why the technique is called as attenuated total reflectance. This technique gives the best result out of infrared reflection techniques. Now, there is something called as specular reflection. Specular reflection is observed from in general. If you say forget about IR, in general visible light के लिए अगर हम बात करें, the specular reflection is observed from glass, mirrors, and all that. That is basically when it is the surface is very smooth. So from source, most of the light is get reflected. Then next is diffused reflection, also called as drifts. We will see what drifts is. It is combination of internal and external reflection. This is external reflection. This is internal reflection. Uh, See, IRS basically stands for internal reflection surface. ERS stands for external reflection surface. And there is something called as DRS, that is diffused reflection surface. So in diffuse reflection surface, light when incident on the surface, it get scattered in all the directions. Basically, these surfaces are rough in appearance. Now, this is all these three are sampling technique only. We are still in sample handling, sampling techniques. So what is basic of these three techniques? It involves measurement of reflected energy from the sample surface at given angle of incidence. If you change the angle of incidence, the energy that is reflected will also change. The electromagnetic reflectance depends on the angle of incident of the illuminating beam. Then the refractive index and thickness of the sample, it is contributing to the more or less absorption of the infrared radiation. And third is experimental conditions. Now experimental conditions will generally involve uh, the temperature of the surrounding and moisture content of the atmosphere and so on. Okay, types of specular reflectance experiments. There are three types. All these three we have seen. That is the reflection of absorption of relatively thin films. Okay, this is a reflection or a refractive substrates measured at near normal angle of incidence. Means, we show you what it means. Suppose this is your sample surface. So reflection absorption. Let me draw a laser light. Suppose it is IR light. So whatever is angle of incident is almost same as angle of incident and reflection. So they are almost same, very narrow angle. Okay, then specular reflectance. It was a reflection absorption or attenuated reflectance. Second is specular reflectance, measures relatively thick samples measured at near normal angle of incident. So this is also near to the normal of the angle. Third one is angle of reflection absorption of ultra thin films. This is extremely thin films or monolayers deposited on surfaces. When we talk about monolayer, we generally talk about uh, a single layer of molecule deposited on surface. It is measured at a high angle of incident. That means if this is the normal, the angle of incident will be very high. So let's study the first technique, attenuated total reflectance. These ATR, attenuated total reflectance, it is assembly which comes as adapter. Like you have the main device of IR spectroscopy. One part is removed and this ATR part is attached at its place. So ATR accessories are especially useful to obtain IR spectra of samples that cannot be readily examined by normal transmission method. So जिनका normal absorption or transmission method possible नहीं है, for only those sample ATR is very useful. They are suitable for studying thick or highly absorbing solid and liquid materials, including films, coating, powders, threads, adhesive, polymers, and aqueous samples. So what is condition? They should be highly absorbing. Okay, they should be highly absorbing is the condition to use ATR. ATR requires little or no sample preparation for most samples and is one of the most versatile sampling techniques. Now, this theory of ATR. Before going into theory, I will quickly show you the diagram so that you will understand the theory better. See, this is your sample, green color. Green color sample is attached to one crystal. Now this crystal has optical density such that IR beam can pass through it. It has called as internal reflection element, or it is simply called as ATR crystal. This assembly, what you are looking in front of you, is single bounce ATR. That means light is coming and bouncing from the sample only once. This is incident beam, this is reflected beam. At the point of impact, if you draw a normal, you will get theta as angle of incident. At the point of impact, the IR radiation slightly penetrates into the sample. The extent to which it penetrates into the sample, it generates evanescent wave. Basically, if even if you are when you are looking at say the whiteboard and I'm projecting the laser around the laser point, there is certain region where there is actually no laser falling, but still it is glowing in the red light. So it is evanescent wave area. Okay, so let's come to the theory. ATR occurs when a beam of radiation enters from more dense, that is, when we say more dense, it is optically dense with higher refractive index into a less dense medium with lower refractive index. The fraction of the incident beam reflected increases when the angle of incident increases. So what this means to say, I will show you. If you go on increasing this theta value, the reflectance angle will also go on increasing. This is pretty much understood. Okay, the fraction of incident beam reflected increases when the angle of incident increases. All incident radiation is completely. There was one notification. I think someone raised their hand by mistake. Okay. All incident radiation is completely reflected at the interface when the angle of incidence is greater than the critical angle. What is critical angle? It is a fraction, it is a function of a refractive index, the angle of incident beyond which rays of light passing through a denser medium to the surface of a less dense medium are no longer refracted but totally reflected. If you go on increasing this angle, there will be one point where the light will not get refracted, it will simply get uh, totally reflected. So no refraction occurs. The beam penetrates a very short distance beyond the interface and into less dense medium before complete reflection occurs. Okay, I will read this point again. The beam penetrates a very short distance. See, this is very short distance penetrated by the wave beyond the interface and into the less dense medium. That is, we are talking about this less dense medium before complete reflection occurs. And after penetration, it reflects back. This penetration is called as evanescent wave and typically is at the depth of few micrometers. It is very small area. Its intensity is reduced, means attenuated. The intensity of infrared radiation is attenuated by the sample in the regions of the IR spectrum where the sample absorbs. So only those wavelengths which are absorbed by the sample will get attenuated. All other wavelengths will get perfectly reflected. So this was single bounce method. Now, the sample is normally placed in close contact with a more dense, high refractive index crystal. So, understand that it is when it is said that it is more dense, it is optically more dense than air, but it is perfectly transparent for infrared radiation. High refractive index crystals such as zinc selenide, thallium bromide, thallium iodide, or germanium. The IR beam is directed onto the behaved edge, that is sloping edge of the ATR crystal, that is this edge, sloping edge of the ATR crystal, and internally reflected through the crystal with single or here you can see the single reflection. The number of reflections and penetration depth both increases with increasing angle of incidences. So if you go on increasing this theta value, the value will also increase for the reflection. The number of reflection and penetration depth both increases with increased angle of incidence. For a given angle, the higher length thickness ratio of the ATR crystal gives higher number of reflection. Now that can be seen over here. See, this is, I will highlight the part. Okay, this is your ATR crystal or IRS element. Okay, you can keep sample on its one of the surfaces. From here, infrared radiation is entering. From this surface, it is bouncing. This is first reflection. This is second reflection, third reflection, fourth reflection. So with every reflection, there is more and more penetration, and those typical wavelengths will be absorbed by the sample more and more. So you will get better results. Part okay. Functions, factors influencing ATR analysis. Wavelength of the IR radiation, that is lambda. Then refractive indices of sample and IRE. Then angle of incidence of IR radiation, depth of penetration, sample and IRE contact efficiency. They should be in perfect contact. There should not be any gap in it. So this is the result with different angles. It is the another presentation of that multi-bounce ATR cell. Okay, to summarize ATR, it is a versatile technique. It is non-destructive technique. It is used for variety of materials. Then it requires either no sampling or very minimal sampling, sample preparation. Then it is useful for surface characterization. It is also can be used for opaque samples, where it is just bouncing off from the surface. It is not complete penetration. It has limitation also. It is sensitive typically 3 to 4 orders of magnitude less than transmission. Next is specular reflectance. Now, here you will see that there is no element present immediately in contact with your sample. Okay, it is for smooth surfaces like films, bulk material which is very fine, and it is for monomolecular layer on substance material. Third type is diffused reflectance. In diffuse reflectance, you have very uneven surface. So electromagnetic radiation bounces off in all the directions. So what is done is, in a cup, you will keep your sample and you will use ellipsoid mirror to collect the radiation reflected in all the direction. Then it will be directed to the detector. So application of drips, strongly absorbing samples can be analyzed like coal, pharmaceutical plastics, small and irregular samples, also powders. Then what are advantages? Minimal sample preparation or even no sample preparation, sample is not destroyed. Okay, this is little repetition. Now we are moving towards the application part of it. The application in qualitative analysis. Qualitative analysis, identifying what is present actually in the compound. We are moving towards the end of this chapter. Use of identifying organic and inorganic biological species. The time required to perform a structural determination was reduced by a factor of 10, 100 or even 1000 by FTR modern instrument. You don't have to change your wavelengths. All the wavelengths are bombarded simultaneously. Identification of organic compound is a two-step process. Step 1 is it involves determination of what functional groups are present, what functional groups are most likely present by examining the group frequency region. And second step that involves detailed comparison of the spectrum of unknown with spectra of pure compounds that contains all the functional groups found in the first step. So basically in here you are analyzing the fingerprint region. Now fingerprint region, it extends from 1200 to 600 centimeter inverse and is particularly useful because small differences in the structure and composition of a molecule results in significant changes in the appearance and distribution of the absorption peak in the region. Now, if you will see, this is fingerprint region and this is functional group region. In functional group region, you can observe peaks for functional groups, and these peaks will be characteristic for particular compound. So this is The spectra in front of you is for n-hexane. Now, no two molecules will give exactly same IR spectrum. Exception is enantiomer. This is your GPAT question. Enantiomer give same IR spectra. Now, group frequency region, that is, this is the group frequency region. It stretches from 1200 to 500, and from 400 to 1200 centimeter. It is fingerprint region. It is actually very complex. It is complex like your fingerprints. But as fingerprints are characteristic of person, this fingerprint region peaks are characteristic of the compounds. Now, you will need to remember this, memorize this. This is asked in exam also. Group frequencies. The approximate frequency or wave number at which an organic functional group such as carbonyl CO, C double bond C, CH, carbon triple bond carbon, OH, absorb infrared radiation can be calculated from masses of atoms and the force constant of the bond between them. So we can know mass of carbon, we can know mass of oxygen. From experiment, we can find out force of that bond between oxygen and carbon. And we can actually calculate the infrared radiation frequency using the formulas that we have discussed in the theory. Now, these frequency called group frequency are seldom totally invariant, that is fixed value. Because if you attach to, I will ask you a simple question. Okay, this CH bond in this compound and this CH bond in this compound, will they absorb at same energy level, at same frequency? Both of them are same only. Both of them are CH bonds, but will they have, because other functional groups attached to them are same. But although it will not be exactly same, but it will be near to each other. The value of frequency will be near to each other, although not fixed or the same value. Okay, a range of frequency can be assigned within which it is highly possible that absorption peak for a given functional group will be found. So instead of giving one number, a range of frequency numbers are given to a functional group. Now, these go through this table. These are different bonds, these are type of compounds, and these are frequency range. Now, in IR spectroscopy, although they say frequency, it is understood that it is a wave number. Go through this table, I will give you 2 minutes. This table you need to mug up in examination. Question is asked like that, see, give stretching for carbon-oxygen bond, give say for carbon-oxygen bond, and you have to write those values. Okay, let's talk more about fingerprint region. See, there are small differences in the structure and construction of a molecule result in significant change in the distribution of absorption peak in this region. Like if you change from say position substitution at ortho position to para position, we explain this is ortho di substitution and this is meta di substitution. So although all the functional groups and all everything is same, only the connectivity is different. So because of the difference in the connectivity, you will get large change, significant change in the fingerprint region of the spectra of these two molecules. Maybe the functional group region may be same. What will change is right hand side, that small area fingerprint region will change. As a consequence, a close match between two spectra in this fingerprint region constitutes strong evidence for identity of compounds yielding the spectra. Exact interpretation of spectra in this region is seldom possible because of the complexity of the spectra. So never, when you are showing interpretation, never try to show interpretation in the fingerprint region. It is only used for differentiation. Like this is for CH stretch, this is for CH bend, and none of the peak here is marked for identity. Can you identify this compound? What compound it is? Which compound is that? Has everyone asleep? नेम द कंपाउंड स्टूडेंट्स. लास्ट लेक्चर है, सर ने इतने सारे कंसेप्ट एक ही लेक्चर में पढ़ा दिए, सबको अभी नींद आ रही है. Okay, Maipal has answered 2,3-dimethyl butane. Sakshi has answered 2,3-dimethyl butene. She saw double bond somewhere, I guess. Zenith is saying 2,3-dimethyl butane. So yes, it is 2,3-dimethyl butane. Okay, anyway. So in the left hand side of the spectra, that is the functional group region, you can see only two types of peaks. One for stretching, the other for bending. Now there are two peaks for bending. See the next compound. Can you name this compound? Yes, very good. So both of them are showing very similar peak for stretching and for bending. Now, if I see only this half of the spectra and remaining half right hand side is say covered, I will not be able to differentiate between these two compounds. But only when I see the fingerprint region, this region of the spectra, I can differentiate that these two are not same compound, they are different compounds. I hope you understood it now. Okay, let's move forward. Observe the spectra. Here you can observe peak for hydroxyl group over here. This is typically around 3,400 to 3,500. This typical hydroxyl peak. And there is a CH peak as usual. Observe the left hand side of spectra. The characteristic standout peak for alcohol is hydroxyl. Now, although we say that do not observe the fingerprint region, this there are certain bonds like carbon halogen bonds. They give their identification peaks in fingerprint region. So, like all the rules, this rule also has got exception. You know, observe the another presentation of the same thing what we have studied in the table. Halogen is missing here. You can add halogen. Now, basically, nowadays computers are used for identification of the compounds from the given spectra because they can compare huge number of data simultaneously. So, for your sample, it will take a spectra and it will compare that spectra with huge number of known spectra. Okay, manually it will be very difficult. So, computers are used. So, like computer. Now, this is not transmittance on y-axis, it is absorbance. That's why you are looking mountains, not valleys. So for example, say computer has obtained this spectra of a known compound. When it is comparing that with its database, it came across this particular spectra in say database of USP. It came across this data, this set of data. It is for benzene. So this compound, what it will identify unknown as it is benzene. Now, let's go for manual interpretation of the spectra. So there are, you can say, different flow chart to how to go about interpretation of the IR spectra. This is the most widely accepted. Whenever you see IR spectra, first thing as a step one that you are going to do is look for the carbonyl bond ka peak, which appears as a strong band at 1820 to 1660 centimeter inverse. Now, contains absorption band in a spectrum. Okay, it will absorb very strongly. It will have a medium width. See, medium width means this is a narrow peak, it is a wide peak. So in between them, you have a medium width. If you see the carbonyl band, look for the other band associated with the functional group. If there is a carbonyl group, what compounds can be possible? It may be aldehyde, it may be ketone, it may be ester, it may be carboxylic acid, it may be amide. So considering that, you look for those bands. Okay, look for other bands associated with functional group that contains the carbonyl by going to step number 2. If this is the possibility that when CO is present, what if there is no CO present? If there is no CO present, check for alcohols and go to step number 3. So first we will check step number 2, assuming that we have got carbonyl group. If carbonyl group is present, we want to determine if it is part of an acid or an ester or aldehyde or ketone. At this time, you may not be able to distinguish aldehyde from ketone? As of now, you cannot distinguish. इसके लिए भी है कुछ distinguishing. Let us first check if it is acid. If it is acid, you will get OH group. Now, OH group for acid, this is highly polar bond, so it has absorption near 3,300 to 2,500 centimeter inverse. Now, it may happen that this particular P actually will overlap with CH stretch. There has to be CH stretch if it is organic molecule. There will be carbon-hydrogen bonds. There will be a CO single bond band near 1100 to 1300 centimeter inverse. If it is carboxylic acid, there is CO bond which we have just identified in the first step, and there will be another CO bond which is a single bond that will give stretch at 1100 to 1300 centimeter inverse. Now, after that, look for carbonyl band near 1725 to 1700 centimeter inverse. Now, here you have very broad range in step number 1. If there is carboxylic acid present, in that range you still have a narrower range, 1725 to 1700 centimeter inverse. Are you with me, students? Are you getting it? कुछ समझ में आ रहा है क्या? Okay, at least 2 students have replied. That encourages me. So let's go forward. Suppose ये acid नहीं है, so it may be ester. If it is ester, so ester का functionality क्या है? COO है, and it is alkyl group here. So you don't have OH group. Okay, मतलब ये जो band यहाँ पे था, जो हमको मिल सकता था हाइड्रोक्सिल के लिए, किधर गया? Okay, this will be absent. Okay, then what else will be present? Let us see. Look for CO absorption of medium intensity into 1300 to 1000 centimeter inverse. So this is approximately same as CO stretch over here. So whether it is ester or acid, this bond over here will be always present. So it will give a stretch. So what is distinguishing between these two? Presence or absence of OH bond, OH band, I'm sorry, hydroxyl band. I hope acid and ester is clear to you. Let's move on to aldehydes and ketones. Aldehydes is ketone. Can you tell me which bond is distinguishing between these two? CH bond. Very good. Very good. Very good. Mahipal Pureval. Very CH bond is distinguishing. So it has to be that carbonyl ka carbon and when aldehydic hydrogen bond, it should be characteristic for aldehyde, which will not be present for ketone. So look for aldehyde types CH absorption band. Now they have specified that aldehyde type. They have not simply stated CH bond. Okay, it is aldehyde type CH absorption band. Now these have 2 weak absorption to the right of CH stretch near 2850 centimeter inverse and 2750 centimeter inverse. So these two bands will be observed always if aldehydic CH is present. Now it is caused by the CH bond that is part of CHO aldehyde functional group. Now after that has been confirmed, look at the carbonyl band around 1740 to 1720. Now again I will repeat. In step 1, this is huge range, 1820 to 1660. Out of that range, you need to look for this range, small range, if you think aldehydic carbonyl group is present. Okay, so first you will observe for aldehydic CH. If aldehydic CH is present, then go for this. Okay, now if aldehyde is not present, so it may be a ketone. So the weak aldehyde CH absorption band will be absent because you don't have that carbonyl carbon and hydrogen bond that is not present. So look at the carbonyl band only, and for ketone it will appear at 1725 to 1705 centimeter inverse. I hope this carbonyl ka logic clear to you. We are coming to the end of lecture. Do you have doubt? Can you please tell me? We are looking at only one functional group. We have to go a long way. There are many functional groups. Okay, looks like nobody is asking the question. We will revisit this carbonyl group tomorrow again. tomorrow or whenever our lecture is. It is on Friday. Anyway, start giving your attendance. Start with roll number 1. I can see 10 students absent today. Let's see if we end up with 10 students absent. Chaitanya, start with roll number 1.